Hey guys, how's it going? Mr. Mitchell here. In this video we're going to go over question 1 from the 2023 SQA Advanced Higher Physics exam paper. So let's get into it. Question 1 says a hot air balloon accelerates vertically upwards from the ground. During the first 8.0 seconds of flight, the vertical velocity v of the balloon is given by the relationship v equals 0.0044 t cubed plus 0.012 t squared, where v is measured in meters per second and t is measured in seconds. Using calculus methods, part A says to determine the vertical acceleration of the balloon at t equals 8.0 seconds, and you'll see there's 3 marks available for this. Well, since we're given this expression for the velocity v in terms of time t, to find acceleration we want to differentiate the velocity v with respect to time. So we can say that a equals dv by dt, which remember is just an equation on your relationship sheet, and we can say that's equal to d by dt of our expression for v. So we've got 0.0044 t cubed plus 0.012 t squared. So to differentiate, remember we bring the power down and multiply it by this number in front, and then we take 1 off the power. So this will become 3 times this number t squared plus 2 times this number t to the 1, which is just the same as t. So if you put that into your calculator, it will simplify to 0.0132 t squared plus 0.024 t. And remember we were asked for the acceleration at a time of 8.0 seconds, so all we need to do now is sub in our 8.0 seconds into this. Now we want to substitute the time value of 8.0 seconds in, so we have a equals 0.0132 times 8.0 squared plus 0.024 times 8.0. And if you put that into your calculator, you should get an answer of 1.0 meters per second squared. Part B says using calculus methods, determine the vertical displacement of the balloon at time t equals 8.0 seconds, and again there's 3 marks available here. Well, remember if we want to find displacement and we've got an expression for velocity, then we need to integrate the velocity v with respect to time. So we could write that v is equal to ds by dt, which remember is just an equation on your relationship sheet, and that's equal to 0.0044 t cubed plus 0.012 t squared, i.e. our expression for velocity. And now we want to integrate both sides, so we can ignore this v part now because we've got this ds by dt expression for the velocity instead. So integrating this side and this side, we have the integral of ds by dt is equal to the integral of 0.0044 t cubed plus 0.012 t squared dt. So integrating both sides with respect to time here. And we've just used brackets on this side to show that we're integrating both parts of this expression. Well, on the left hand side, remember integrating velocity with respect to time will give us displacement s. So we could write that s is equal to 0.0044 t to the 4 divided by 4, because remember to integrate we raise the power by 1 and divide by the new power. So we have this t to the 4 divided by 4 plus 0.012 t cubed divided by 3, where we're raising that power by 1 and dividing by the new power, plus the constant c. And then we can simplify these fractions to make it look a bit nicer. So you can do that in your calculator to get s equals 0.0011 t to the 4 plus 0.004 t cubed plus c. And now to get rid of this constant, we need to consider the initial conditions, which remember is just what happens when time t equals 0. So we can say that at time t equals 0, the displacement s equals 0 because the balloon hasn't moved anywhere yet. So therefore, if we plug in t equals 0 in there and s equals 0, then that means c must equal 0. So simplifying this becomes s equals 0.0011 t to the 4 plus 0.004 t cubed. And lastly, we need to substitute the time value of 8.0 seconds into this expression to find the displacement. So if we do that, we get s equals 0.0011 times 8.0 to the power of 4 plus 0.004 times 8.0 cubed. And if you put that into your calculator, you should get an answer of 6.6 meters. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video one of these, subscribe to the channel, and I'll see you in the next one. Take care.